Good evening, friends, my dear students. Welcome back to Learning Mathematics in our channel of mathematics, Learning Mathematics, class 12 mathematics. So, welcome back, each and every one of you. A very good evening to all of you. For us, of course, at the moment, those who are watching at the moment now, yes, a very good evening to each and every one of you. Patagrano Tumsumana Super Music. Okay, Tisana Takiala, Banda Mari Shibona, Tokiria Villa, Tihamran, Villa, Nimula, Shibula, Priyanshu, Landuina. Very good evening to all of you. Okay, it's Lee. Alright, good evening. Good evening to each and every one of you. So nice to see you again. So I guess all of you have come prepared. Get your book, pen, textbooks, notebooks, copies, everything ready so that we can begin in just a moment or two. So last time, actually I missed out somehow question number 7. So we're going to start from there, question number 7. We will start from question number 7. Okay. I hope all of you are doing well. Stay safe also. Wear your mask also every day. And stay safe. Only we can take care of ourselves. So please be careful in moving around. Do not go out until and unless it's necessary. Please stay at home. Stay safe. Hello, good evening. In the meantime, as we wait for some of your friends, more of your friends to join, you can get the question ready there. Intiala, good evening, good evening. Yes, welcome back. A very good evening to all of you. All the regulars are regularly joining the classes. It's nice to see that. Imsotila, good evening. Alright then, so shall we just begin? Inasanla, good evening. So shall we just begin then? The other friends will definitely, I guess, will be joining very soon. Lono, yeah, good evening. Good evening to each and every one of you. Takujongla, Lono. Alright, good evening. Okay, Sangeeta, Afterlife. Okay, Hilal, yeah, Hilal, good evening. Kimikali, good evening. Ash, let me pronounce this properly today. Ashley Kevry, Afterlife, because this you are also a very regular attendee here in our classes. So today I'll pronounce your name properly. That is Ashley Kevry, Afterlife. Okay. So Panglamla, good evening. A very good evening to all of you. All right. So let's continue with our exercise. So as I was telling you, last time we missed out question number 7. So today we'll just start from here, question number 7, and definitely we'll solve each and every question of this particular exercise so that we can move on to the next exercise. Okay. Now here, it's the same question, the question that says using properties of determinants and without expanding, proof. So far the proofs that we have been doing, everywhere it was like equal to 0, wasn't it? It was equal to 0, equal to 0, equal to 0, but and then of course just one question, that was number 5, where you had to prove that it's different, it's another determinant. Except that question number 5 and all the other proofs, we have been proving that it's 0, 0. It's just this question again that's like, we have to prove that the value of this determinant is 4a square b square c square. A square b square c square we can prove. So I may be wrong in guessing that, but I guess the question is slightly wrong actually, without expanding. So there is no property of matrix which actually, as far as I know, as I say, I'm a person with limited knowledge, so I'll look into it again. Then yeah, a very good evening. I'll also look into it, but I do not, as of now, I'll be looking into it very soon. But as of now, I do not recall any property of determinant which gives us like 1. So until unless we expand, there is possibly no way to find the value of a determinant, and until and except if it's 0, then definitely we can prove. So of course we will try, but I don't think without expanding it's possible. Okay, but we'll try to use the properties as much as possible, and then only when our properties are over, maybe that time with the minimum expansion, I guess we will go for the expansion. But I guess there is, especially that part without expanding part, I believe there is a small mistake with that question. But I'll also look into it again. But as of now, I don't think that is very much correct without expanding. Okay, because this is not any determinant property doesn't give us the value of a determinant to be at least 1 that I don't recall of. So anyway, let's just continue. So now, so from here, that's from 7, 8, 9, 10 onwards, what happens is always do look at the proof. Okay, look at the proof, and not only this, right from the beginning of the exercises, always do look at the proof and keep an eye on this right hand side. This is something like one hint that we usually use. It's like a thought process. Okay, it's like a thought process. So before we really start solving, we should first analyze the question and then see what properties can be done, because the right hand side will tell you exactly what you're supposed to do. That's something like a hint that is already given to you on the right hand side or the proof. So you really have to look into it closely and then apply some thought to it. Then yeah, of course you will get to understand that with practice, as I always tell you. Thought process. All right, another hint that is like we should always try to create the right hand side factors. Okay, we should always try to create the right hand side factors in the left hand side determinant. It's like step by step. I'll try to create more and more right hand side factors like a square, b square, c square as we go on solving the left hand side. So these are, as I was saying, these are just basically like thought processes, so which will help us in getting our proof. So blindly we just do not start with the left hand side. Okay, Achit Puman, good evening. So with that in mind, let's just begin. So I'll rub this off now, the left hand, right hand side. So I need a square, b square, c square. So let's keep that in our thought LHS. So what we can do is one of that property where we can take common from any row or any column. So from column 1, I can take a common. So that leaves me with minus a, b, c. From column, I'm just taking common, so no problem with that. From column B, I'll take B common. So that will be left A minus B, C. And from column 3, I'll take C common. So that's like A, B minus C. Done? Similarly, so this is A, B, C. Again continuing, at once I cannot do that. So it's a step-by-step process. Again, from row 1 this time, I'll be taking A common. So I'll be left with minus 1, 1, 1. It's a simple question actually. Again, from column row 2, I'll take B common. So 1, minus 1, 1. And from row 3, I'll take C common. So that's like 1, 1, minus 1. So the right hand side, the left hand side, one part of the proof already we do have, that is like a square, b square, c square, isn't it? So we just need that 4. That's what I was telling you. I believe there's a small mistake with that question, because how do we get that 4 with expansion only? Without expanding, we just cannot get the value 4. So that's where I have some reservations regarding the question. Okay, but anyway, as of now, I'll look into it. If the question, if it's not wrong, then definitely I'll be updating that very soon. So now let me just expand this. Maybe what I can do is apply some operations, and at least we can try that. At least we can try to do that, like reduce the determinant, that is maybe R1, I'll just apply R1 plus R2. So R1, if I apply R1 plus R2, minus 1 plus 1, 0, 1 minus 1 again 0, 1 plus 1, 2. R2, I'll apply R2 plus R3. So at R2, I'll apply R2 plus R3, R2. So 1 plus 1, that's going to give me, let's apply R2 minus R3, that will be better. So 1 minus 1, 0. Minus 1, minus 1, minus 2. Isn't it? Minus 1, minus 1, minus 2. 1 minus minus plus 1, so that's again 2. 1, 1, minus 1. So at least we can do that so that the expansion would be minimal. So a square, b square, c square. Now just expand along this. Okay, so I'll be just expanding along this element. So this element is what? A 3, 1. So 3 plus 1, that's going to be 4. Along in A, directly also you can apply, because see, this z will be 0, this will be 0, or no problem, let's just not confuse. What was this value? This was, come on, this was 1, isn't it? Yeah, 1. So I'll just expand maybe along, fine, R1, no problem, I'll not confuse. So it's going to be 0, so 0 into anything is 0, minus 0, again 0 into any value is 0, plus 2 into this determinant. So 0 minus 1 2s are minus 2. So I'll not confuse you with any other expansions. We'll just expand along R1. That is what we have been doing with determinants now. So this is like 0 0. So 2 into minus minus plus 2. So definitely that gives us 4a square, b square, c square. So that's the proof verification. Sanjini, good evening. Okay, so that's how it can be done. So I'll definitely look into it. But as I say, I definitely think that the question, there's a small mistake with the question. Okay, without expanding, it's going to be slightly difficult, I guess. I'll give it a try. If the question is fine and no problem, then definitely yes, I'll correct it. Question number 8. I hope you've understood. No? Fine. And question number 8 now, this time, yes, just like 7 only actually. By using the properties in exercise 8 to 14, show that. So now there is no restriction. We can go for expansion also. But of course, yes, we have to use the properties. So if without using the properties, if you start your expansion directly, now that may be termed, I guess, wrong. Because the question is telling you use properties of determinants. So without using properties of determinants, if you directly jump into the expansion part, then I don't think that will be termed very much correct. Okay? So you'll have to use at least one property, After that, yeah, you can expand, but you have to use the properties. Question is telling you to use the property. They're giving you the freedom to expand. So this is the question. I'm going to start with the left hand side directly. So I hope you've given the thought process there. What was the proof? The proof was on the right hand side. You had to prove that you have to get the factors a minus b, b minus c, c minus a minus b, b minus c, c minus a. That's what I was trying to tell you. You'll get the hint from the question itself. So it's like b minus a, what was it? A minus b, sorry. A minus b, b minus c, and c minus a. So you try to use at least one of these hints given to us. So that means R1, I will apply R1 minus R2. R1, I'll be applying R1 minus R2. Of course, anyway, you will get the question, but let's just try to apply here. Let's say R1 minus R3, then give it a try. R2 minus R3. Let's just apply the steps. You can see this is not absolutely, I mean, like, these are not the only steps that you will apply. Okay, you can apply any steps. I'm just trying this. This might be a little bit easier, I guess. Let's just see. So R1, 1 minus 1, 0. That means R3 I'm not changing. 1 C squared. So R3 I'm not changing. R1 and R2 only I'm applying the operations on. So 1 minus 1, 0. A minus C. A square minus C square. And R2 minus R3. 1 minus 1, 0. B minus C. B square minus C square. Alright, because when I do this, I already have some factors that are along with it, no? B, C, and all. Don't worry, we'll get the factors, don't worry about that. So now then, if I just expand along this column 1. But before I expand, let's try to do something like 0, 0, 1, A minus C. A square minus C square, we can again write as A minus C, A plus C. No? A plus B into A square minus B square formula. B minus C, C. B minus C, B plus C. And C square. We can do that. There are many ways to do. Okay, not just one particular way. Simplification. Tomorrow you tell me to do what I might just do it along another one. Along another method. So once that is done, I can take A minus C common from row 1. So what elements will be left there? 0, 1, A plus C. Because when you are about to expand, the smaller the terms you have, like 1, zeros and all, the easier for you. So that's why I just decided to do that. B minus C taking common, 0, 1, B plus C. And here of course 1 C squared. So definitely this will be easier for me for my expansion. That's what I'm trying to do here. So A minus C, B minus C. Now expanding along this column 1. 0, 0, done. 0 into anything is 0, so 0, 0. And column 1, this is like last time I tried. A, 3, 1. 3 plus 1, 4. So that's just going to be 4. 1. Just 1 plus 1 into. So this determinant of this value, isn't it? So B plus C minus A plus C determinant. So that's going to be A minus C, B minus C, B plus C minus A minus C. So C cancels. So A minus C, B minus C, B minus A. So we almost have the proof. It's just that we have A minus B. So here I can take a minus common, A minus B. No problem with that. We have B minus C, that's already there. And C minus A, C minus A. So here also if I take a minus common, C minus A. And this is fine, B minus C. So then minus into minus, these are all products only. So minus into minus plus. So I'll just arrange and write. That's A minus B, B minus C, C minus A. So that's your right hand side, that's the proof. So it's more about your simplification also. Okay, knowing the properties, and yes, simplification also will matter. So the more problems you solve, the better you will become, don't worry. Alright, let's move on to the next question. Number 8, the second one. Simplification part you can also do. Second one is 1A cube, 1B cube, 1C cube is equal to A minus B, B minus C. This will always be cyclic. C minus A, A plus B plus C. So again, it's almost the same question. This time I believe column wise. So it's almost the same question. The factors that we have is A minus B, B minus C, C minus A into A plus B plus C. Of course, we have A cube, B cube and all, so no problem. Find that. This is the proof. These are the factors. So that means I just have to subtract. Starting with this time column wise. A minus B, B minus C, C minus A. So which one you do, that completely depends on you. So what shall I apply here? Maybe this time I'll just apply C1 as C1 minus C2 and C2 as C2 minus C3. Okay, I'll just apply stepwise. Okay, C1 so that there is no confusion. So C1 is C1 minus C2. So apply and see what do you get. C1 as C1 minus C2. So in the meantime, I'll be actually that step can be used, but fine, I'll not apply it now so that there is no confusion. Actually, we can do that also directly also until unless I'm not changing C2 now or C3 and all. So C1 minus C2, 1 minus 1, 0, A minus B, A cube minus B cube. Then again, I will apply C2 as C2 minus C3. For those who can, that's what I was trying to tell you. You can apply these two steps in one step also, if you think you will not confuse. 1 minus 1, 0, I'll have B minus C, B cube minus C cube, 1 C, C cube. Okay, fine then. So, हो गया लो, काम खत्म. So just expand along. And we can take the common out now also, later also, that depends on you. What shall we do? Okay, let's just reduce a little bit. No? Actually, we can do that also. Directly multiply. Which one shall we? Okay, just B minus C. B cube minus C cube, same formula. B minus C. Algebraic identities. B square plus BC plus C square. The last column remains the same, 1C C cube. So from column 1, I can take A minus B common. From column 2, I can take B minus C common. So what is left? 0, 1. A square plus AB plus B square. Here, 0, 1. B square plus BC plus C square. 1 C, C cube. A minus B, B minus C, expanding along row 1, so 0, 0, that's all 0, so just 1 into B square plus BC plus C square into 1 minus 1 into A square plus AB plus B square. These are thought processes only, so we can do it with thought process only. So now there's 1 into this minus this. So since this is 1 only, I'm not writing down all those stuffs. So A minus B, B minus C, B square plus BC plus C square minus A square minus AB minus B square. So B square, I think can be cancelled. So then A minus B, B minus C, BC minus AB plus C square minus A square. A little bit of arrangement is always needed. Okay, systematic approach. You should know what is your proof. So from B, I can take B common. So it's going to be like C minus A plus C square minus A square can be written as C minus A into C plus A. That A square minus B square formula only. So I guess we almost have the proof. A minus B, B minus C. From this I can take C minus A common. So that's like C minus A common. So that's like B plus C plus A. So that's the proof. A minus B, B minus C, C minus A. Just arranging this A plus B plus C is equal to RHS, hence the proof. So actually it's more than the properties, it's about our calculation only, simplification, more than the properties. So we really have to be patient, good presence of mind is necessary. Okay, rubbing off. You can get ready with number 9. 1, 2, 3. Number 9. X, Y, Z. X square, Y square, Z square. X square, Y square, Z square. Y, Z, X, X, Y. I guess it is always cyclically. Most of these questions, X, Y equal to X minus Y, Y minus Z. X minus Y, Y minus Z, Z minus X. Isn't it? X, Y, Y, Z. I'll just write here. X, Y plus Y, Z plus Z, X. That's the proof. There. Okay, I am rubbing off the proof part. Left hand side. Done, no? Okay, so what do I need here? Almost the same question again. I need X minus Y, Y minus Z, X minus Y, Y minus Z. I'm not going to be getting anything from here. Okay, I'm going to do something here. Listen carefully. I will multiply X on row 1. That means row 1, I'm going to multiply by X. I'm just writing it here with pencil. If you wish, you can write down. So that's going to be X square, X cube, X, Y, Z. So if I multiply, I have told you we have to divide. Last class we talked about this. Properties also. Here I'll multiply by Y. Y square, Y cube, again X, Y, Z. I got that from this term because if I just put X, X, Y, Z, Y, Y, X, Y, Z, Z, X, Y, Z, common. It's all going to be same again. This one I'll multiply by Z. Z square, Z cube, X, Y, Z. So X, Y, Z. After that, again taking X, Y, Z common from column 1. So X square, Y square, Z square. X cube, Y cube, Z cube, 1, 1, 1. See, actually this 1, 1, 1, no, that's another, like, we take it as a hint, something like that. Like 1, 1, 1, always, we try to get this 1, 1, 1. It does help us in our calculation, no? It does simplify us, help us simplify our calculations much easily. So that's one thing that we always try. We try to get this X, 1, 1, 1. How do we do this? It's something like, as I was telling you, out of practice, after years of studying, practice, definitely teaching also has helped, because teaching gives us more experience. So with experience, actually, we learn. We are not born knowing everything. Hence, we get to know all this stuff. Because teaching and learning are two different stuff. Learning, we just learn without knowing actually what we're learning. But when it comes to teaching, then like, oh, we also have to again start learning before we really start teaching our students. So that's why teaching always has helped us. So XYZ, finish, goli maro, khatam. So here what I'll apply this time is I will apply R2 as R2 minus R1. And R3, I'll apply R3 minus R1. So that means R1 I'm not going to be changing. X squared, X cubed, 1. Here I'll have Y squared minus X squared. Here I'll have Y cubed minus X cubed. Here I'll have 0. I'll have here Z squared minus X squared. Z cubed minus X cubed. 1 minus 1, 0. Yes, time to expand again. This time along this, because these two elements will be 0. So 1 into Y square minus X square, Z cube minus X cube, minus Y cube minus X cube, Z square minus X square. Other elements will be 0. Because zeroing any element will be 0. Okay? I could have expanded here also, but this time I'm just doing without expansion. Because here I guess it will be much more convenient. So let's see what expansions can we do here. So this is y plus z into y minus z. This is z minus x, z square plus xz plus x square minus, I'll write here, y minus x, y square plus xy plus x square, this one, z minus x, z plus x. Alright, this is y minus x. So y minus x, a common term, z minus x, another common term. So y minus x, z minus x, a common term. So what is left? These two terms. So I'll just start multiplying. Okay, instead of writing it down, I know that I have to multiply. So I'll just start. Okay, let me just write y plus x, z square plus xz plus x square minus z plus x, y square plus xy plus x square. So that's y minus x, z minus x. Alright, let's begin our multiplication. yz square plus xyz plus x square y. Don't be bored with these calculations. You have to do it quickly without wasting much time. Xz square plus x square z plus x cube. Okay. Minus. So minus, this is all plus, so all the terms will be negative. Alright. So y square z minus xyz minus x square z minus xy square minus x square y minus x cube. So x cube done. X square z done. xyz done. X square y finish. How many terms are left? 1, 2, 3, 4. So that's y minus x, z minus x, y z square plus x z square minus y square z minus x y square. So these 4 terms are left for us. So I'll do a little bit of arrangement. Y minus x, z minus x, y z square minus y square z plus x z square minus x y square. More about calculation over here. In the proof, I see x minus y. Okay, z minus x, we still have to carry on, I thought. So if I take y, z common, what is left here? Z minus y. Plus, if I take x common, I have here z square minus y square. X, z minus x, y, z minus y, x, z minus, come on, z minus y, z plus y. This exercise is going to take a really long time. After that, please don't run away. Please be there. Let's finish this today. I need your support, moral support. So z minus y common. So what is left? I still need that second bracket. Yz plus x into z plus y. Already shaping up. So now you see. We'll do it directly, okay. Class 12 standard, these things can be done. X minus y. X minus y, y minus z. So from here, negative, if you take common, reverse, minus, plus. Now, thought processes, we can do this directly. So, x minus y minus z, z minus x. Yz plus x, z plus xy. I think that's xy plus yz plus xz. That's it, that's the proof. All are positive values, so you can arrange if you wish. You can arrange the proof and say that, okay, this is what we have right inside. Happy now with the textbook? Yeah. Otherwise, you can leave it there also. It's all the same. Okay. So, determinant property, though, we use only 1 or 2 properties. More problems we were having with the simplification part. That's why I was telling you to be patient. Okay, fine. Shall we? 5, 4, 3, 2, 1. Next question, number 10. 1. Chalo, if you haven't liked the video, please give me a like also as I write down the question for you. If you haven't subscribed, please subscribe also as I write down the question for you. If you haven't shared, share also as I write down the question for you. Chalo. Okay, this is I think going to be an easier question. Because could you get the hint from the question there? Try to get as many factors on the left hand side of the right hand side. 5x plus 4. What if I add all the elements of a column, of a row, or all the elements of a column? 2 plus 2, 4 plus 1, 5. 5x plus 4. 5x plus 4. So, column wise, row wise, your wish. Okay, column 1. Column 1 plus 2 plus 3. No? 5x plus 4. 2, 5x plus 4. 2, 4, 5x plus 4. The rest, forget it. Not interested. So then you know what to do. 5x plus 4 common. 1, 1, 1. Yeah, we got 1, 1, 1. So that's now easy for us to calculate. Always tell that to yourself. Okay, now I can do. Because I have 1, 1, 1. Yeah, no, it's going to be easy. I used to get happy when I used to do this. 1, 1, 1. Halfway done. That means my proof is almost very near. Self-motivation, very important. Self-motivation. You always have to uplift yourself. Self-motivate. Self-motivate. So after that, R2, you can apply R2 minus R1. R3, you can apply R3 minus R1. 1, 2x, 2x. 1 minus 1, 0. The other proof was 4 minus x. So x plus 4, x plus 4 minus 2x. So that's 4 minus x. That's why. 4 minus x. 2x, 2x, 0. Again, R3 minus R1, 0, 0, 4 minus x. You have the proof. So 5x plus 4, chalo, expanding along this, other elements are 0, 0, and row 0, so expanding along this column 1, or row 1 also no problem. 1 into 4x minus 4x, 4 minus x, 4 minus x, minus 0 into 0. The other terms all 0 only. That's why we use these properties, as I was telling you, to, these properties are for what? For expansion, better expansion, easier expansion. 5x plus 4. Not to build rockets. 4 minus x whole square. Proof. Done. 4 minus x whole square. 5x plus 4 and 4 minus x whole square. right. Okay. Before it really gets boring, I would be so happy if all of you could just type a hi to me so that I will know that you're not sleeping. It might get boring, not just sitting and watching and watching and watching. So give me a hi. You should, whoever is online, let's see. Let's do a quick hi to each other as I write down the question. Chalo, in the comment section, please give me a type of hi, type. Let's see by the time I finish the question and turn back how many highs do I get. Not that hi, but hi, hello. Alright, let's see. Okay, I got a wrong hi, it's Lee, hi, no, she gonna hi, Ashley, okay, Ashley to be hi, no, hi, she gonna upang nan banazan kita, tapos kung natin simulan, kasi na rin mo nga, pitigil no, kinikali, no, yeah, Tuparam, me also, standing and teaching, around hi, hello, Sumla, hi, Msotila, Kinkali, Rosundula, hi, around hi, Nini, I, no. So, Jona, Priyanshu, Lance, alright, that's good to see all of you giving me a hi. So, I guess, I'm sure now you're not sleeping, so. Alright, so let's move on to the next question. That's question number 10-2. So nice to see you participating. I'm blessed. Nasallah, hi. Atin also, finally he thought, okay, chalo, let me just give you hi. Okay, chalo. So this also almost the same question like the first one. Here also we'll have the entire hint 3y plus k. 3y plus k, so y plus k. No? So I guess you know what to do. Usually, by the time classes are over, it looks like I've put on makeup, all the chalk. Finally he said hi. Okay, hi. Hello. Alright, so we know again what to do, so it's going to be same C1 plus C2 plus C3. So y, 3y. 3y plus k, y, 3y plus k, 3y plus k. I think same kind of a proof, nothing much to change. So let's get this over quickly. So again 3y plus k common. So 1, 1, 1. Y. I don't know why, because it's y, full of y only. Y plus k. So 3y plus k. Same operation will do. R2 minus R1, R3 minus R1. I'm going to rub this operation so that it doesn't get confusing. So 1 y, I don't know because it's full of y. R2 minus R1, 0, y plus k minus k, so k, y minus y, 0, y minus 1, 0, y minus y, 0, y plus k minus y, so again cancel. So 3y plus k, again 1 into k square minus 0. The other terms will be all zeros only. Okay, so that's the proof, isn't it? K square into 3y plus k. Chalo, let's get ready with number 11. Done? Chalo. 11. Since I promised you that I'll be doing all the questions, I love the finish up. Please do remember, I keep on saying that the method that we are applying here today, this is not the final, this is not the only way to solve. In mathematics, as I always say, there are so many ways in which you can do a particular problem. Provided it's technically and mathematically correct, you are entitled, you are eligible for the marks. Okay, so always do remember that. Because as I always say, 1 plus 1, how much? 2. Half plus half plus half plus half. That's also 2. So it depends on the way the person writes. But yes, it has to be mathematically correct. So there can be other ways also in which the problem might be easier than the way I do also. Okay, so you can do those also. No problem. No problem. As I always again say, motive is the final bottom line is students should learn. That's what we try to do. As long as students are learning, yeah, we can sacrifice. So a plus b plus c, I need a plus b plus c. Wala comma bhi jai se. Chalo, my comma also. Kamar gaya. Chalo, left hand side. A plus b plus c. So a plus b plus c. A plus b plus c. I need positive values. A plus b plus c. If I add, so minus b plus 2b plus b minus c plus 2c plus c. Same terms here. Here also. Fine. Then let's apply R1 as R1 plus R2 plus R3. Corresponding elements of R1, I'll apply R1 plus R2 plus R3. So I'll just show you one, that is A minus B minus C plus 2B plus 2C. So that's going to be A minus plus minus, but plus B plus C. Here also same, A plus B plus C. Here also A plus B plus C. Two B, 2C. B minus C minus A, 2C, 2B, C minus A minus B. So we know what to do. A plus B plus C common. So one term is already common here. Again, yeah, we almost have the proof. Done. So one factor we already have, A plus B plus C. I need two more. But of course it's 1, 1, so fine, no problem with that. So we just apply this operation. I think that will be easy because minus minus 2 we can take common and we can just add, so not a big issue with that. I don't want to be experimenting things now. So 1 minus 1, 0. Again, 1, I'll show you b minus c minus a minus 2b. So minus 2b. So minus a minus b minus c. 2c minus 2c, 0. 1 minus 1, 0. 2b minus 2b, 0. Again, minus a minus b minus c. We can do it here itself, or we can just expand. Okay, a little bit of arrangement again. Minus common. Then I'll expand. That'll be easier. 1 into this. So it's minus into minus, that's already positive. So a plus b plus c whole square minus 0. The other terms will be all 0. So then we have the proof a plus b plus c whole cube. Okay? Chalo, one more done. Move on to the next question. Number 11. 2. I guess that one you can give it a try, can you? 11-2. Question number 11. I'll just give you the hint, okay? Question number 11, number 2. What you can do there is you just apply 2x, 2x, 2x. Just apply this operation C1 plus C2 plus C3. Yeah, that will tell you exactly what to do. That will exactly, yeah, okay, because she's also tired, I guess. Anyway, I'm also tired. So you just apply that operation will tell you exactly what to do. So you will exactly know how to proceed, because similar questions we have already solved. Okay, so we'll move to number 12. Got it? 12. Number 12. Question number 12 is saying 1 x squared x 1 x squared x 1 is equal to 1 minus x cube whole square. That's the question. So we'll go for this proof also again. This problem is also loudly telling us do this, do this, do this. Because looking at the terms. How do we get to understand this? As I was telling you, these are developed with practice only. But very loudly it's telling us exactly. Because you see, that particular formula, a cube minus b cube, that formula is a minus b into a squared plus ab plus b squared. I can clearly see that in these terms, because 1 minus x cube, that's like 1 cube minus x cube will be like 1 minus x, 1 square plus 1 into x plus x squared. So that's going to be like 1 minus x, 1 plus x plus x squared. It's like very loudly telling us. It's like very loudly telling us, do this, do this, do this. So if I just add row 1 or column 1, all the terms, I think that will get our job done. Okay. Alright, so if you may begin wondering, hey sir, how did you do that? I just told you, I was not born with it. But this comes with practice. Definitely one day you will also be able to do that. Definitely, I'm sure you will also be able to do that. Because whoever is attending the classes here now, I'm sure that you are eager to learn. It proves that since your presence here proves that you are eager to learn. So definitely, I'm sure you will be able to get that. Okay, definitely. Alright, so only 3 more problems to go. Let's have the patience. Chalo, almost done. Fine. Chalo, this time what shall we do? This time give me a yo. Come on. This time give me a yo. By the meantime, I'll just get the question ready. Yeah, come on, come on, come on, come on, come on. Yo, yo, yo. Give me a love or a yo. Give me something, give me something, give me something. Come on, type, 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 type. In the meantime, I'll get ready. I'll get the question ready for you. Okay, Rosentula, what's that like? Okay, that happens only once in a while. Okay. Alright, so fine. That was a rare moment. I also do not know how I did that. It just happened. Okay. Alright then, let's continue with our question. Just 3 more problems to be. No. That just happens once in a while. Even I'm also surprised how I did that, but it just happened. So, chalo. I don't think it's going to happen again. So, anyway, like. Alright, let's move on to the question now. Okay, so we'll just apply the operation now, c1 plus c2 plus c3. So 1 plus x squared, 1 plus x squared, 1 plus x plus x squared. X, of course, we have to write it properly, otherwise the rows and columns have to be really arranged properly. So after that, we know what to do. 1 plus x squared common. 1, 1, 1. Let me just write it down a little bit below. So it's like 1, 1, 1, x, 1, x squared, x, 1. No, every session I'll try something different. So next session, let's see what I can do. I guess next session I'll try something different. I'll learn from you youngsters. Next session, what's the latest in trend? You have to teach me, of course. You guys are getting old now. Old but young. Okay, so once we know already what to do, isn't it? So let's get this over quickly. R2, R2 minus R1, R3, R3 minus R1. So this will remain x square, 1 minus 1 0, 1 minus x minus x square, this 0 again, x square minus x, 1 minus x square. X square minus x, okay, so 1 plus x square. Okay, I'll just do a little bit of simplification here again. 0, 1 minus x common, so 1 minus x, 0, x common, x minus 1. 1 minus x, 1 plus x. So 1 plus x square. From this row 2, I'm going to take 1 minus x common. Okay? From this row 3 also, I'm going to take 1 minus x common. Now look at the twist here. 1 x square. This is 0, 1, x. 0. This was not 1 minus x common. Of course, here we have 1 minus x common, but it's not here. But no problem. 1 minus x, that means minus x. That negative, I've just done it directly. Class 12 standard, these are simple stuff. 1 plus x. I think that's alright with you. I could have easily written another step again, taking minus common, 1 minus x. Why do that when we already know how to do it? So I've just done that directly. Okay? Let's just expand this now. Log 1. So it's 1 plus x minus x square. The other terms will be 0. So 1 plus x into minus x into x, that's minus x square. So all right. Okay, next. Let me do question number 14. 13, we can give it a try. Okay, we'll do one more question, that is question number 14. You can give it a try. If not, you can let me know. Definitely, I will help you to do that. Okay, so let's do question number 14. Or you want me to do 13 also, or you will give it a try. I guess that is fine for all of you. What I've done is I've just taken so that I can take A common from row 1, B common from row 2, C common from row 3. So that's what I've done here. So here only, just to take that A common, I've taken A common from these two terms. So A common from A square, A. 1 means 1 by A, so that A into 1 by A is also 1. Mathematical terms, simple maths terms. Same with B common here from, so B common means B plus 1 by B, and C common means C plus 1 by C. So if I do that, I can take A common from row 1, B common from row 2, C common from row 3. So that leave me with 1 by A, B, C. Here, B, C, B plus 1 by B, and here C. And from here, C common, so A, B, C plus 1 by C. Done? Okay. Then what can I do here? Actually, here I think it should be A because I'm taking B common, so A. Please correct it. B. So B common, so A will be left. There's C. Yeah, that's it. So, okay, R2, R2 minus R1, R3, R3 minus R1. Let's see what we can do here. Like R2, R2 minus R1, R3, R3 minus R1. So A plus 1 by A, B, C. A minus, so minus 1 by A, B 1 by B, C minus C 0. And here again minus 1 by A, B 0, C 1 by C. Next, multiplying column 1 by A. This is slightly complicated, but I have to do it. So if I multiply column 1 by A, I have to divide by A. Multiplying column 2 by B. So I have to divide by B. Multiplying column 3 by C. So I have to divide by C. Something like multiplying column 1 by A, column 2 by B, column 3 by C. So automatically taking the divisor also out, that is dividing by A, B and C. This comes from the property itself. Okay, so if I do that, then what can we have? So A, this is cancelled, so this is 1 into A into A square plus 1 by A. This is minus 1, minus 1. This is B square, 1, 0. C square, 0, 1. So here A and A can be cancelled. So we'll just expand along maybe any one expansion. I'll just expand along row 1, no problem. Expansion will give me the same. So 1 plus A square into 1 1s are 1 minus 0 minus B square minus 1 into minus 1 minus 0 plus C square 0 into minus of minus 1. So that's 1 plus A square minus B square into minus 1 plus C square into minus plus 1. So that's 1 plus A square plus B square plus C square. So it's slightly different in this particular question. So that's to prove anyhow 1 plus A square plus B square plus C square. So there can be some other ways also, I believe, to solve. So you can try. This is also one way to solve. So this will give you a lot of practice on the properties, what we can do with determinants and all. Okay, so that's it. All right, quickly let's do the multiple choice question also. That will not take time. 15. This one I've already given you a property on that. No? So if A is a square matrix of order n, then K times of A is, determinant of K times of A is nothing but K power n into determinant of A. So this is a 3 by 3 matrix, so it's going to be K cube of A. Simple as that. Okay, the last one. Quickly. Which of the following is correct? Number A, I'll write in short only. Determinant, come on, is a square matrix. Determinant is a square matrix. Absolutely not. Determinant is not a matrix at all. Determinant is not a matrix. So how can determinant be a square matrix? No. Determinant is a number associated to a matrix. No, this one is also not true. Why? Because there's a small problem here. Determinant is not a number that is associated to any matrix, because except for square matrices, we don't have the value of a determinant. If it is a rectangular matrix, then its determinant does not exist. So determinant is a number associated to a square matrix. Yes, this is the correct one. Definitely none of this. No, that's not the correct one. Number D, absolutely not. But yes, determinant is a number that is associated to a square matrix. That is true. First one, no, because it is not associated to just any matrix. It's associated number associated to only a square matrix. And definitely determinant is not a matrix. So just to confuse you. Alright, so I believe number 13 you should be able to do it. I believe you will not have any problems with that. You can give it a try. If not, you can let me know in the comment section below. Definitely I'll solve it and upload it to you for you. Okay, so no problem with that, but you can give it a try. So alright then, whoa, that was really a very long session. So anyway, thank you for having the patience to be in the classroom working out together. Okay, so that was fun teaching all of you guys again. So I'll see you again tomorrow. I mean the next session with the application of determinants. That's area of a triangle. A small session the next class. Okay, so thank you so much each and every one of you for being a part, for always again motivating, for your kind participation. That always motivates me. So thank you so much. We have had a lot of fun today. So thank you so much, each and every one of you, and thank you. And yes, a very good night to all of you. Rest well. I'm also going back to rest now. For some time, I'll be coming back again. So fine then, do encourage your friends also to join us. And do continue to share. If you still haven't subscribed, please do subscribe also. Alright then, thank you so much. Thank you. Have a good time, all of you. Study well. Stay safe. Alright then, I'll see you in the next session. Bye-bye.